Welcome. So today, we're going to pull back the curtain on the world of data science. We're going to break down how all those little clicks and swipes you make every single day are actually part of a much, much bigger story, and how that story gets written. So let's just start with a quick question for you. I want you to think about your day so far. Every website you've visited, the apps you've used, maybe even the places you've been. What do you think that digital breadcrumb trail says about you? Because, whether you realize it or not, every single interaction, I'm talking everything from paying with a credit card to posting on social media, is generating data. We're all constantly contributing to this massive, ever-growing ocean of information. And that, right there, brings us to the fundamental quest of data science. How in the world do we navigate this huge ocean of information? How do we turn all these raw, meaningless numbers into something we can actually use? Okay, let's start with this. The number 42. By itself, what does it mean? Anything? Nothing? Right now, it's just a raw fact kind of floating in space with zero context. And that's exactly what we mean when we say data. It's the absolute starting point, a raw, unorganized fact. It could be a number, yeah, or a word, or some kind of measurement, but on its own, it really doesn't tell us a whole lot. Now, look at this. This is where it gets really interesting because context changes everything. If 42 is a patient's temperature in Celsius, well, they have a dangerous fever. But if it's in Fahrenheit, they have severe hypothermia. It's the exact same data point, but with just a little bit of context, it tells two completely different and very urgent stories. That's the leap from data to information. But, we can go even one step further. See, knowledge is about applying that information. Knowing that 42 degrees Celsius is a high fever means you understand you need to take action. You call a doctor, you find some medicine. It's the information combined with experience. And if you want a perfect, maybe even painful example of why this is so critical, here you go. In 1999, a simple mix-up between metric and imperial units caused NASA to lose a $327 million Mars orbiter. So yeah, precision and context. They aren't just academic ideas, they have huge, expensive, real-world consequences. Okay, so we get it. Data needs context. But what forms can data even take? It's not always just a bunch of numbers in a spreadsheet. So let's take a look at the different building blocks we can use to create that knowledge. Take a look at this butterfly. To you and me, it's a beautiful image. But to a computer, it's a highly structured grid of numbers. Every single pixel is defined by a value for red, green, and blue. This is a fantastic example of what we call structured data. It's organized, it's predictable, and it's super easy for a machine to process. Understanding the structure is really the first step to unlocking what's in the image. But data isn't always about a thing. Sometimes it's about the connection between things. This graph here shows who follows whom on social media. The really crucial point is that by analyzing these relationships, you can uncover hidden communities, you can find influencers, and you can see how information flows. The knowledge isn't in the dots themselves, it's in the lines connecting them. And this is where data gets really, really powerful. When you start layering different types of information, like, say, maps, property lines, and customer locations, you can uncover a much richer, deeper understanding. No single layer tells you the whole story, but when you put them all together, they reveal these complex patterns you absolutely would have missed otherwise. All right, so now that we have a better handle on what data is, how does it actually become useful? Well, to figure that out, we're going to follow the journey of data through something known as the data lifecycle. So this is basically our roadmap. Data goes through 6 key stages. You capture it, you store it, you pre-process it, then you analyze it, visualize it, and finally, you publish it. Let's break down what each of those really means. First up is capture. So how do we get the data in the first place? Sometimes it's straightforward, but other times it's incredibly clever. Have you ever filled out one of these reCAPTCHAs? Well, you're not just proving you're a human, you're actually helping to digitize old books that computers can't read. That's crowdsourcing data capture in action. The big challenge here, of course, is always quality control, making sure the stuff you capture is accurate right from the start. Next, we have storage. Once we have the data, where we put it, and more importantly, how we format it is absolutely critical. This 5-star open data scheme shows you the difference. A PDF? It's barely usable. It gets 1 star. But linkable structured data, that gets 5 stars because it's ready for anyone to come along, reuse, and build upon. The whole goal is to make data findable and accessible, not just lock it away in some digital filing cabinet. Stage 3 is pre-processing, and this quote really says it all. Garbage in, garbage out. Now, this is often the most time-consuming part of the entire process. Some people say it can take up to 80% of a data scientist's time. But it makes sense, right? Because no matter how sophisticated your analysis is, if your data is messy or inconsistent, your results will be totally meaningless. This is the crucial cleanup step that ensures the quality of everything that follows. So the final 3 stages are where we bring it all home. Analysis is where we get to build models to find those hidden patterns. Visualization is how we turn those patterns into charts and graphs so our human brains can actually see the trends. And finally, publication is all about sharing the results, closing that loop so that other people can use our work and build on it. So we have this entire journey, right? But who are the guides? Who are the people actually doing all this work?
Well, there are 2 key roles here. Think of the data scientist as the strategist. They're focused on the what. What are the right questions to ask of the data? Then you have the data engineer, who's the builder. They focus on the how. How do we create the systems and the pipelines to get the answers? So, for example, a data scientist might ask, what marketing campaign will boost sales for this product? The data engineer then builds the system to pull all the right data so the scientist can actually find the answer. They're really 2 sides of the same very important coin.
Okay, this brings us to our final destination. After this whole journey, from a single raw number to a sophisticated model, what's the ultimate goal? I mean, what are we really trying to achieve with all this? I really love this quote from Jeff Leake. The key word in data science is science, not data. And the point he's making is crucial. It's not just about collecting mountains of data. It's about the process, the curiosity, the hypotheses, the rigorous method of turning that data into discovery. It's about being systematic in our search for actual knowledge. So as we wrap all this up, I want you to think about this. All of this data and all these processes, they are essentially creating a brand new language for us to understand the world. And that leaves us with one final and I think really important question. If data truly is a language, what stories do we want it to tell?